Now let us take one more question. Which of the following acid gives isopentane on decarboxylation with soda lime? See, the options are this, then this one. Okay. Now, first of all, what is decarboxylation? Removal of carbon dioxide in the form of carbonate. And the reagent used here is soda lime, a mixture of sodium hydroxide and calcium oxide in 3:1 ratio. And what is isopentane? You need to be clear about this. Isopentane is this. Say this arrangement is iso. You already got 3 carbons, take 2 more. Now this is isopentane. This is what we need to prepare. Now what happens during decarboxylation? Let us see even that also. The basic reaction is, say in decarboxylation, when sodium salt of carboxylic acid is heated with soda lime, this is what is eliminated and we get alkane. So the overall thing is we are going to get something with 1 carbon less than the parent acid. Let us check. Now in the first case, let us just remove this for convenience. Yes, we got our isopentane. Okay. Then even the second one also. This is our isopentane. How about C? Yes, even in the third one also it is isopentane what we are getting on decarboxylation. Need to be cautious. And how about this? When you remove this, the thing that you are getting is not isopentane. The thing that you are going to get is isobutane. So this is wrong. And the final answer for this is A, B, and C. Hope this is clear. Okay. Let us take one more. 2.84 gram of methyl iodide was completely converted into methyl magnesium iodide. On decomposition, using ethanol, the volume of gaseous hydrocarbon produced at NTP will be a different variety. Let us first see the reaction. Methyl iodide was completely converted into methyl magnesium iodide and treated with ethanol further. Look at this. This is methyl iodide. Now methyl iodide reacts with magnesium metal in the presence of dry ether to give methyl magnesium iodide. Now this methyl magnesium iodide is treated with ethanol. Et refers to ethyl. Now it's just like the hydrolysis of Grignard reagent. This is acidic or active hydrogen. Now this will go along with methyl and we get methane, right? Of course, the byproduct is ethoxy magnesium iodide. Forget about that because they are asking the volume of gaseous hydrocarbonate entity. I mean this. Let's check. Now, because the weight of methyl iodide is given, consider this and take the weight of that. But before that, let us consider the number of moles. Equations are all balanced. Let me go for methane. Of course, in this case, they have asked volume. We'll be considering. What is the gram molecular weight of methyl iodide? 12 plus 3, 15, 15 plus 127. Iodine, 142 gram of methyl iodide is giving rise to 22.4 liters of methane. A simple stoichiometric problem. 142 grams of methyl iodide is liberating 22.4 liters of methane at STP or NTP. So 2.84 grams liberates how much? Very simple. Doubled divided by 100. Double it, 44.8. Divided by 100 will give you 0.448. That's it. Different variety. Okay. Which of the following will not be obtained in the given Woods reaction? See, this is a radioactive carbon. Consider it to be C14. This with sodium in dry. Let us see the option. So these are the radio isotopes. See the position of radio isotope. So these are the four options given Let us check this out. Now, we know the mechanism of Wood's reaction. Let's see what happens. Let us go with the free radical mechanism. Say this particular bond undergoes homolytic fission. Upon which we get a free radical. Now this is allyl free radical. See, allyl free radical is of course resonance stabilized. Let's say the other resonance form of this. Consider the homolytic cleavage of this particular pi bond. These two free radicals are generated. And now let us form a bond between these two and keep this one free. Okay, then we get this. You got free radical over here, but this is the one with radioactive carbon. See, the radioactive carbon has not changed its position. It is still there. Only thing is, because of resonance stabilization or because of the resonance thing, what has happened? The free radical is formed on a different carbon, right? Now, let this be the first variety. This be the second variety. The only thing is, either you take two free radicals of the first type or two radicals of the second type, club them up, or one radical of the first type and one of the second type. That's it, club them up. Let's see. What if two radicals of the first type are clubbed? Simple. This is where you are going to add another. This type of a thing is added. So when you take this way, you get a bond here with, just for clarity's sake, I'm giving this. You will, of course, have a bond here when a similar thing is added, right? So what do we get? It's the first one we get when two free radicals of the first type are added. Hope this is clear. Now, what if two free radicals of the second type are added? Okay, it is this. Two free radicals of the second type are added. Now the connection will be here. Then we have only one possibility. Two free radicals, one of each type, when added, this will just come and get added here. See the position. That is your third one. First and second are added. And of course, we don't get this one by any means. So this is an interesting question. Check this out. Next. How many distinct dichlorination products can result when isobutane is subjected to free radical chlorination? Okay. See, we have seen questions on monochlorination, but this one is dichlorination. And the alkane taken is isobutane. Let's see. See, this is isobutane. What happens when this is treated with chlorine in the presence of sunlight? Of course, dichlorination. What all are the different possibilities that we get? See, because these three are in the same environment, and only this one is in a different environment. Let's see what all we get. Let me take this variety. Okay. This is in fact 1, 2. Correct. Uh, Not only these two, any of these three with the middle one will give you the same. So don't go for the other one, other things, right? Now the second one that is possible is this. Keep it the same way. How about this? One, two, then 1, 3. That's it. Anything else is possible. Any of these three, I mean, two of these three will give you 1, 3. Because it's, of course, symmetric. Any two of these three will give you 1, 3. Any one of these three with the second one will give 1, 2. That's it. Only two distinct varieties. Distinct. This is on dichlorination. Next. Which of the following reaction produces the same product? C3HEI with the bromine in the presence of sunlight. Further, with sodium in ether. First one. Then the second one is COOH with sodium hydroxide on electrolysis. Bromine with magnesium ether. Then with methyl bromide. And with the red phosphorus hydrogen ion. Yes, it has different preparation methods of alkanes. Check out the first one. They have given propane, C3HEI. Now, of course, we get two different types of products because we got hydrogens in two different environments. But this one will give us the major product. So let me go for that. So this has to be CH3, CH, Br, CH. Now this is Wood's reaction, right? What do we get? Simple mirror image of this particular species. Let me write that. It is this. You add a similar kind of thing. This is what you get, right? It's simple 2,3-dimethyl butane. Now go for the second one. Now here we get the sodium salt of the given carboxylic acid. Of course, the given carboxylic acid is 2-methyl propanoic acid. Now this on coal base electrolysis, even in coal base also, which goes via a free radical mechanism, we get a free radical over here. Hope you know this. On electrolysis, two such things dimerize and give you this product. Say the full mechanism. Now going for the third one. Formation of Grignard reagent. Now on further reaction with methyl bromide, it's very simple. Remove MgBr2, add CH3 over there. What do we get? A CH3 here need not be written, of course. Then hydrogen iodide and red phosphorus, a reducing agent. See, when carboxylic acids are subjected to reduction, I mean, if we take RCOOH, we get RCH3. That means in place of COOH, we get CH3. So here also the product is 2,3-dimethyl butane. So in all the given things, we got the same product. Okay. A, B, C, D, or 1, 2, 3, 4. Okay.